Okay, thank you very much for clicking on this video. This video is actually made or tailored for SS1 students in St. Finbar's College. The reason why I put it on YouTube is because for direct consumption of my students, so that they will not say that the video wasn't reachable. So I want you to know that it's a revision that has to do with your first term and second term in preparation for exam on 27th March, which is on Monday in St. Finbar. So if you have these 15 points I'm going to discuss here, I believe you are well prepared for your 2022-2023 second term examination. So I group this thing into two, session A and session B, or we call it first term and second term work, since we are in second term as this video is being made. So I want you to look at what I would like you to study. Look at this. Changes in chemistry. We have two types of changes in chemistry. One is physical change, and we have the other called chemical change. Try to get the definition of physical change, chemical change. For me, I prefer you using a beautiful definition like this. For physical change, you can just tell them, if for instance they ask you to define physical change, you will just tell them that physical change is a type of change in which no new substance is formed and it is easily reversible by physical means. Then you go to chemical change and tell them new substance is a change where new substance are formed and it is not easily reversible by physical means. So when you tell them this, if for instance they are even asking you to look at differences, even from the definition you have already given the first point, and if you look at the definition, you have no new substances formed, you go to the other side and tell them new substances form, and you just pick another one from that definition again, you can get another one. But you need to get up to 4 differences between the physical and the chemical change. Also try to get to know examples of them. Try to study about 8 examples of physical change, 8 examples of chemical change. If for instance you don't have enough in your printed work of last time, you can consult new school chemistry, you can consult essential chemistry. It will help you to know that. A bonus point I would like you to look into here is physical and chemical properties. Try to know them is also important in this exam. So note 2, sulfur. This sulfur is actually SULPHUR for British students, but for American students the sulfur is correct, so don't bother. So the green part represents electron, the blue part represents proton, and the black part represents neutron, and they are all giving signs: negative for electron, positive for proton. So the cluster of this positive and neutron, that position they are found, is called the nucleus. Sometimes some people will use circle to denote it for you. So that is the nucleus. Then the circle away from that nucleus is called K shell. And here we have only 2 electrons that can be found there. The circle above the K shell is called L shell. It is the second shell now, so it contains only 8 electrons, and the last circle, or the outermost circle, contains only 6 electrons. You can count it by yourself. You notice that. So this 286 is an example of what we mean by electron configuration. If you can be able to understand this of sulfur, I believe if you practice others, it will help you to grow better and prepare very much. Note 3, what I would like you to note again in this is atomic model development. In atomic model development, we have some people like Dalton's atomic theory. He has his own model. We have J.J. Thomson model. We have Rutherford's model. We have Niels model. So these 4 people, they contributed to the development of atomic model, although they are still working on it till date. So at least this 4 persons, if you can be able to know what they contributed, just write out what it contributed. For instance, J.J. Thomson discovered electron. If you just say something like that, that means that you have a little idea of what the question they might give to you in exam. So point or note 4 you are going to look into is Dalton's atomic theory proper. I said it before here. And you need to know the first 4 postulates of Dalton's atomic theory. There are 5, but you need to know the first 4 postulates. The 5th one does not have a problem, so we don't really talk much about that. So you also need to know the discoveries that counter the postulates, like discovering of radioactivity, where new atoms can now be created and destroyed. This reactivity, which leads to nuclear reaction, has made that atom can neither be created nor destroyed to be invalid. So find other things that are discovered that actually counter this Dalton's atomic theory, the first four postulates. And also you also need to look at modification of Dalton's atomic theory. It is very, very important, because if you understand these discoveries, you can just tell them, okay, because of this we can change the way Dalton's atomic theory appears. What I would like you to note again is elements. If you can be able to get element compounds and also get the idea of mixtures, is very, very important. So note them and know the difference between elements, compound, and mixtures. No matter how, get at least eight examples of elements, eight examples of compounds, 8 examples of mixtures. So note 6, what I would like you to look into, note 6 is metal. Actually, elements are divided into metal, non-metal, and metalloid. So you actually need to know the definition of metal, and you actually need to know the definition of non-metal and metalloid. If you even have opportunity to look into noble gases. Now, I just want to put a little word on this. For metals, they form ions by losing electrons. Non-metal, they form ions by gaining electrons. Metalloid, they are in between metals and non-metals. Noble gases, they don't form ions. So they have complete octet states. Now you need to know examples of this metal. Something like sodium is a metal. Non-metal, we have something like bromine. For metalloid, we have something like silicon. For noble gases, we have something like helium, neon, argon, and krypton, radon. Those ones you will see at the extreme right hand of a periodic table. That is what we mean by noble gases. That means that they have complete octet state. That is something I need you to put in your head. That is note 6. Then note 7, what I would like you to also look into will be electronic configuration. Electronic configuration is very, very important here, and I have some example like hydrogen. The K shell is 1. If you look at lithium, we have K shell is 2, L shell is 1. You can see it here. And we have something like beryllium. We have K shell is 2, L shell is 2. And we have something like nitrogen. K shell is 2 and L shell is 5. We have something like magnesium. K shell is 2, L shell is 8, and M shell is 2. We also have something like phosphorus. K shell is 2, L shell is 8, and M shell is 5. And we have sulfur that I have actually treated before. K shell is 2, L shell is 8, and M shell is 6. And I want you to know that all these things written here, you can actually create more of them. I've given you assignments on it one certain time. You can actually go back on them and do it on your own. Remember to do it with SPDF too. It is very, very important. So we can actually group elements based on their valence electron. For instance, the last value of N is 5, not 0. The last value of P is 5. So N and P will be in the same group. I don't know if you get me on that. The same thing happens with beryllium, which the last value is 2 and the last value of magnesium is 2. So 2 of them are going to be in the same group. Now, from this idea, we can group elements based on their last values. And those last values in chemistry, we refer it as valence electron. And I call it valence electron number, VEN, valence electron number. So the valence electron number of beryllium is 2. Valence electron number of nitrogen is 5. Valence electron number of magnesium is 2. Valence electron number of phosphorus is 5. You need to know that. So you also need to know what we mean by isotopy, existence of atoms having the same proton number or atomic number but different neutron number or mass number. So if you have this in your mind, you can work. Example of that I normally like my students to use is hydrogen, chlorine, oxygen, carbon. Just use that, you can go. We have another thing we call isoelectronics. What we mean by isoelectronics, that's a particle that have the same number of electrons. For instance, chloride, the total number of electrons in chloride is 18. The total number of chlorides in argon is 18. The total number of potassium ion is 18. See, three of them has the same number of electrons, so we call them isoelectronics. The difference here is that the argon is an element, but chloride ion and potassium ion are not elements, they are ions. And chloride ion is a negative ion and potassium ion is a positive ion. Just look into your notebook. I believe you will understand it much better. So I go for note 8. This is the last part of your first term preparation. You can still go further to do other things because I don't know how the question will look like. You need to study what charge means. You need to know what charge means. Electric charge represents that negative or positive charge possessed by any atom. So you need to know that. You also need to know the valency. Valency of an element is actually the combining power of that substance or element. Look at this. If the charge is -2, the valency is 2. If the charge is -4, the valency is 4. If the charge is +1, the valency is 1. I want you to get that with you. We also have another thing we call oxidation state or oxidation number. 2 of this word means the same thing. This oxidation number is the charge an element appears to possess in a compound or appears to possess in combined state, or we can even say it is the charge an atom appears to have in a combined state. That is what we mean by oxidation state. Sometimes they can ask you to find sulfur oxidation state in H2SO4. You have to do a little calculation on that. Where H is 1 times 2 will give you 2, and you add it to sulfur and add it to oxygen that is appearing 4 there. Now -2 times 4 will give us -8. You sum up all those values, that way you will see your work coming up here. Let me show you what I mean by them. If for instance they ask us to look for H2SO4, so we have to do this thing like this. Hydrogen is 1 times 2 will give us 2, plus X is not giving it because that's the one we are looking for. Oxygen is -2. -2 times 4 will give us -8. And all these things will sum together to give us 0. So if you make X the subject formula, the answer will be +6. Yes, they can ask you something that look like this in exam. That is when they want you to calculate oxidation state of any element in a compound. So you have to know that. So the second session is actually a second term work, and I'm going to rush it a little bit. So in this second term work, I have about 5 things I want you to look into to help you to pass your exam faster. The 3 songs. I gave you people 3 songs. One has to do with mole of a substance is, and I have chemical bonding and also have gas law 1. So if you can be able to listen to these songs, watch the songs, not just listen, not just dancing to the song tunes. No, listen to the song, recite the song, sing the songs, watch the songs, and practice what you say in the songs. So if you can be able to do that, you can do many things in this exam. I believe that. So look into mole of a substance is song, chemical bonding, and gas law. It is on the YouTube already, so you can do that for yourself. Note 2, what I would like you to also look into again after listening to the song and meditating with the songs. Empirical formula. We have chemical formula, and chemical formula are in different ways. One is empirical formula and the other is what we call molecular formula. I just have a sample of what I always tell you people to do when you are doing empirical formula. Try to know the definition of empirical formula. Also try to know the definition of molecular formula. Sometimes these examiners, they can actually ask you something like differentiate between empirical formula and molecular formula. They can actually ask you that. But if you know the definition, when they ask you to differentiate, give them the 2 definition and go your way. Hope you get me on that. So there is a sample work I use here. I'm assuming that A is an element, B is an element, and C is an element. So just look at the activity, the way I did it. Mass, molar mass will give you mole, and the mole, you look for the mole ratio by dividing by the list. But we notice that there's no need of dividing this value because all of them are all prime numbers. That is why when I reached that mole, I couldn't divide them again. Please look at the rule. The rule is mass, molar mass is equal to mole. Then look for the mole ratio. Just I want you to remember the sum, mass over molar mass, that you use it in doing your empirical formula work. So if you have gotten that, the next thing to do is to look for the molecular mass. I'm sorry, this is MASD. It's supposed to be MASS. So you need to do that for yourself. So we go note 3. What I would like you to do again in your book, I would like you to look into chemical reactions. Yes, I know you may be asking, what do I mean by chemical reaction? This is chemical change, and we can actually represent this chemical change with chemical symbols. We can represent it with chemical formulae. We can also, this, when we do that, we are actually doing what we call chemical equation. So look at what definition of chemical equation is. Look at how to balance chemical equation, and look at the information we can actually get from a balanced chemical equation, and also information we might not be able to get from a balanced chemical equation. If when you are doing this, get at least 3 with you. If you get at least 3 points with you, I think you are good to go, because no matter how wicked the examiner will be, it will not give you more than 4. So if you get 3 and 4, you are good to go. So point 4, I would like you to look into ionic bond. You need to know how to use diagram to represent ionic bond. Something like calcium and oxygen to form calcium oxide, potassium and fluorine to form potassium fluoride. If you can be able to draw this, and also be able to draw sodium and chlorine to form sodium chloride, that means that you know ionic bond. And from that song too, you know examples of ionic bond compounds, something like potassium chlorine and potassium chloride, sodium chloride, calcium oxide, and all of them that you have listened in that song. So you can be able to draw the diagram, you are good to go. What about covalent bond? Covalent bond, can you be able to demonstrate how to represent it? Something like SO2, something like CO2. Can you be able to represent it? Can you be able to represent the formation of water? Can you be able to represent the formation of ammonia? If you can be able to demonstrate this, I believe you are good to go. Also know the properties of this ionic bond and covalent bond, because if you know the properties, it will help you. If you don't know the properties, listen to the song again. I listed the 3 properties in that song, and I believe they will not ask you more than 3 properties, because each property you are mentioning is 1 mark. So they will not be freely to give you 4 marks because of the properties of this. So highest they will limit themselves in giving you question. Most examiners is for highest is 3 marks they will give you from this. So the next thing is to look into dative bond, hydrogen bond, metallic bond. So just try to get that. Just get about 3 or 4 examples of each of these and how to demonstrate. In dative bonding, we have ammonium ion, and we also have hydrozonium ion. Can you be able to represent it? If you can be able to represent it, you are good to go. I think the last part of this video is on kinetic theory of matter and kinetic theory of gas. And I want you to go back to kinetic theory of matter. You know, we have diffusion, we have osmosis, and we have Brownian motion that is actually supporting the kinetic theory of matter. And you know that kinetic theory of matter is actually telling us that all matter are composed of tiny particles that are always in constant motion. That is what kinetic theory of matter is saying. Now, we also have kinetic theory of gases. It's also in the song My Gas Law 1. If you listen to the song and play with the song, you are going to get the 5 postulates. Now, in that 5 postulates, I don't think any examiner will ask you to list a 5 to dash you 5 marks. No, to give you 5 marks is not easy. So I believe if you can get 3 of it, which for me, I will tell you, the first line of the song says the gas molecule are in constant random motion. You can leave the second line, or you can just pick the second line. The second line is even beautiful. They have a perfect collision. You can go for the third line. Actual volume of gases are negligible. You can go for the fourth line. The cohesive forces between them are negligible. You have gotten 4. Whereas it is any examiner that is asking you a question from that, highest it will limit you is 3, because giving you 5 marks from kinetic theory of matter gas is not all that sensible. So we go with Boyle's law. You need to know the Boyle's law, know the Charles law, also know how to derive it from that V. Let me show you what I mean by that. You need to be able to derive this Boyle's law from V goes in this form. I hope you get me on this. So if you introduce equality sign, it will change the proportionality sign to become V equal to K all over P. So you can actually make K the subject formula become Vp equals to K. So let me use the other side. This becomes V1 P1 equal to V2 P2. So if you do the same thing with Charles law, you can get something that look like this. So you need to study how to derive this thing. For the Charles law, let me start with this side. It's going to be something like V directly proportional to T, V equal to K, T. If I make K subject formula become K equals to V all over T, then it's telling me that V1 all over T1 will give me V2 all over T2. So this is a simple way of writing the derivation. That is, you are able to move from this place and you arrive this place. That is what they mean by deriving it. So if you can be able to derive Charles law and you put up the formula in your head, please put up the formula in your head. It's very, very important. Remember, the formula for Boyle's law, what we normally use in our calculation is V1 P1 equal to V2 P2. And I always tell students, don't change, don't make anything subject formula here, and always make use of your calculator. Just substitute the values inside this, you will get the answer. After you have written down your parameters, finding your first volume, your first pressure, second volume, and your second pressure. For Charles law, you do the same thing. You know our Charles law will be V1 all over T1. It will give us V2 all over T2. Don't change anything, please. I urge you. Please make use of your calculator. Don't use your brain alone to solve this. I believe God will help you. General gas equation, you also need to know that. Remember that this general gas equation is a combination of Boyle's law and Charles law. You need to know that. Graham's law of diffusion. Watch down my video on remember what we did on our class online. Please make sure you look into that very, very well. And I actually want to thank you for watching this video, and please pay attention to this. If you watch this video, use your pen and write down some things and practice what you have learned. Remember, this is actually meant for St. Finbar's College, Akoka, Yaba, Lagos, Nigeria. But it does not mean that it will not help another person that is not in St. Finbar's in preparation for their second time exam. So I thank you for watching this video to this extent. Remember, this is Chuku A. Marcus.